chips without software is just expensive sand, and not more than that.
From EE Tech Media, this is Moore's Lobby, a podcast where engineers gather to talk all about circuits. I'm Daniel Bogdanoff, your host for Season 3. This podcast literally could not exist without today's guest. Every single stage of the process, from the first outreach email all the way to your device downloading the ones and zeros that make up my voice and this music, relies on high-performance computing. Data centers, AI, cloud computing, it's all happily humming away under the hood of slick web interfaces and podcast RSS feeds. Today's guest has spent the last couple decades ushering in the era of modern high-performance computing, the CTO of Nvidia, Michael Kagan. If you're like me, when you hear Nvidia, the first thing that pops into your head is GPUs and graphics cards, but almost half of Nvidia's business comes from the computing and networking space. It's just that graphics cards are more likely to make headlines or the front page of Reddit. So today we have a rare chance to peek into the world of high-performance computing, which is the core of tech like modern data centers, AI, AR, and autonomous driving. Joining us from Israel, here's Michael Kagan, the CTO of NVIDIA. Michael Kagan, thank you so much for being here. Can you tell us about your background and how you got into engineering?
How I got into engineering, I think basically since the day I remember myself, I knew that I'm going to be somewhere in technology. It started with the family. Both my parents were physicists, but that's where it is now. It turned to be engineering because I wanted to do some more practical things than just, abstract research.
So it sounds like at a young age you knew that's what you wanted to do. Did your parents help jumpstart you down that path?
Well, yeah, my father taught me math and physics, mainly math. So I knew that stuff, and that was fairly fascinating. I also attended this school with some sort of math, stronger on the math.
I don't know if I ever really understood what my parents did until I was an adult.
Well, something you cannot understand, you just need to get used to.
Do you think the philosophy of simply getting used to a technology is something that still applies to your work and our work today?
I think so. There's a lot of things that we are doing. It takes time to internalize and realize, the details. Why, we're now in the space of artificial intelligence and all these neural network models, this is data processing inspired by brain studies, and nobody really knows how brain works. But you do something that looks similar, and then you try to figure out what did you do.
I definitely feel that. I know when I get something working, it's like, wait, how do I replicate this, and what did I actually do? So you got an electrical engineering degree from Technion. What about electrical and computer engineering was interesting for you?
I was looking at the best place to study, and it was interesting. I ended up in the computer engineering. It was in the late 70s. And the last millennium, a long time ago. And those things were very preliminary, and it's sort of, new things that got there. There were no PCs those days. Computers were something which is on the side of the building.
Sure. What would you in college think of you now in the world of technology overall? Did you see a future that looked anything like this?
I don't think I had enough imagination to imagine 40 years ago what would happen now. It will happen with me personally.
And then you spent a lot of time at Intel where there were a lot of computing firsts. Thinking back to those days, what projects stand out to you?
Oh, that's right. Well, in Intel, I started with some vector processor project that eventually was canceled. Then I was one of the designers of the 387 and the 8387. That's Matco processor. Now I'm telling sometimes new hires at Mellanox that there used to be a unit of computing which was outside of the processor. People don't really realize that it used to be the days that calculation was actually outside the main CPU. So that was there. Then I was the architect of the 860 XP. This is the fastest microprocessor those days, outperforming 486 by far. But unlike NVIDIA, Intel didn't pull off the software ecosystem and support for this machine. So it basically gone out of business. Then I was design manager of the Pentium MMX, the first x86 processor that added a new instruction set, extended the instruction set, which was considered fairly revolutionary those days. Then we actually started what eventually turned out to be Banyan's processor, but it was in the very early stages when it just started. I left Intel to start Mellanox, and after 16 years at Intel, that was great, but moved to the next thing.
Those are some iconic chips to computer buffs. Do you have any stories from that era, issues you ran into, or new ground that you broke with those chips?
Well, with the 860, the thing that, and it's sort of closing the circle with the NVIDIA, is when 860 didn't make it as the first and as the leading processor of Intel. By the way, if you will ever asked at trivia which processor Windows NT first booted, it was not x86, it was 860.
Oh, I definitely would have guessed that the x86 architecture was the first for Windows, but it was the 860. Too bad it didn't live on.
Eventually, it didn't get there, but there was a lot of excitement about this architecture and this technology. But anyway, after it was vector processor, very fast on the floating point, and one of the things that was made there out of it was we tried to do the graphics with this chip. Even today, there is no real sort of objective benchmarks on the graphic quality, and those days there was not at all. And there was the sort of benchmark that you have as a jumping ball, that you just look at this animation of this jumping ball and you decide whether it's good or bad.
Funny you say that, because there are still debates on this topic. I overheard one about a display technology that's going to remain nameless. It has very robust electronic compliance parameters, but visually it's difficult to lock into like an official schema of what is, quote, good enough and what looks bad. It's fairly subjective. So how did the bowl look on this processor?
The thing is that it was really cool, except for the moment that ball actually touched the surface. When it touched the surface, it didn't look right. And no matter what we didn't manage to make it look natural. And then what we did, we decided, there was this Disney movies or Disney, cartoons. There's a lot of jumping balls there, and it looks just fine. So let's see, what did Disney do? And so we looked at this, watched it frame by frame, and what happened is the frame that it touched the surface, there is no ball. So it's all about imagination. Okay, and that's look great because everybody imagines this ball touching the surface at his leisure, and that was my first real internalization that graphics and optics is much more has to deal with brain than with the eyes.
So basically, I guess as long as our brains think it's happening, that's good enough. It doesn't have to be frame perfect. Taking a step back, you said there was a lot of excitement about the 860, but ultimately the project ended before it reached its full potential. What did you learn from that? Because this is living proof it's not enough just to have exciting hardware.
Well, what I learned is that chips without software is just expensive sand, and not more than that. You really have to have a great software support. That's, by the way, what NVIDIA did. Unlike NVIDIA is the state-of-the-art vector processors, and it was really hard to program the 860, and it is equally hard, even maybe harder, to program the GPU instruction set level. But what NVIDIA did is they put together a great software support around the GPU and GPU systems. So NVIDIA actually delivering the solution, the computing platform, where the GPU is the main engine, but what user surface and programmer surface is much more convenient and easier to use and intuitive interface how to develop the applications, and not this complex instruction set that like you had on the 860.
I've seen that also today with things like the Arduino, where the value of the Arduino is not just the chip that's $20, $30, but also the whole infrastructure around it where I don't have to go in and program registers with assembly language. The IDE does it all for me.
Yeah.
So clearly the combination of good hardware and good software is critical. That seems to be something that NVIDIA has nailed as well. And I want to talk more about NVIDIA, but the story's about to get more exciting. Can you tell us what you did after you left Intel?
Well, I left Intel to co-found Mellanox, which is the high-speed communication, computer communication company.
Quick side note for you, you may not know Mellanox, but you definitely use their hardware without knowing it. Mellanox was and is an interconnect and networking hardware company, so they make network adapters, switches, and cables for cloud and enterprise data centers. These aren't your typical off-the-shelf switches. It's all based on Mellanox custom ASICs, and Larry Ellison, the CEO of Oracle, described their core InfiniBand technology as faster, more scalable, and providing a higher throughput than other communications technologies. This is super high-tech stuff. Support for the Moore's Lobby podcast comes from Future Electronics. Differentiate your design with microchip 32-bit microcontrollers that provide the performance and functional capabilities to meet the requirements for applications ranging from general-purpose embedded control to secured IoT solutions and beyond. So, if you have 32-bit time constraints, Microchip has you covered on selected cores, and they have stock ready to ship. Their broad and scalable portfolio of devices gives you many features and options to create innovative products. For more information, visit futureelectronics.com. We're back with Michael Kagan, CTO of NVIDIA. Michael, how long was Mellanox a standalone company, and then how big of a deal was the NVIDIA acquisition?
We operated for about 20 years. After 20 years, NVIDIA acquired Mellanox. It is the second largest acquisition at Israeli high-tech.
Wow.
After Mobileye.
So you founded Mellanox in 1999. Y2K is in the news, and the leading search engines are Alta Vista, Lycos, and Yahoo. Mellanox weathered the dot-com bubble burst and continued to thrive. What was the main focus for you in the early days, and what got you through that rough time in tech?
There was a new interconnect technology was developed by the industry called InfiniBand, and we started by implementing this technology. The thing about Mellanox for me, is to build a company based on some core values that I grew up on, and that's how do we get there.
What values?
Excellence. There is nothing is impossible. We were heading up against huge players in the market like Intel, Cisco, Broadcom, big guys. We managed to become the best interconnect out there. Today, InfiniBand is the most advanced, or Mellanox interconnect. Actually, we also deliver Ethernet. It is most advanced interconnect. It is de facto standard of the high-performance computing interconnect. All the big clusters and pretty much across the globe, all the high-performance computers are built based on Mellanox technology.
I think tech history is fascinating, and honestly, I'm in awe of the relentless progress humanity has made in electronics and computing over the last 250 years or so. We've moved from Volta and Galvani using frog legs to detect voltage as we wrestled with the nature of electricity itself, to today's massive supercomputers and spaceships. So I did some digging into the background of InfiniBand. The InfiniBand spec that Mellanox and Michael Kagan built the company around shares a similarity with a lot of modern specifications like USB, PCIe, and DDR. They're the same in that there's not just one single company driving and developing these specifications. If just one company develops and owns a spec, then it's much harder for everyone else to use it. Usually everyone wants their devices to be cross-compatible and play nicely together, but sometimes a company doesn't care about compatibility and wants people to be stuck using only their own hardware. Right, Apple? But that's not the point. We're talking about InfiniBand. InfiniBand was born out of a need for a high-speed serial connection between processors, or CPUs. In the late 90s, there were two groups tackling this challenge. The first was led by Compaq, Hewlett-Packard, and IBM, and they had a tech called Future I/O. And the competing group, led by Intel, Microsoft, and Sun, had a technology called Next Generation I/O. These two groups made peace and formed one super technology called System I/O, but in true 1999 fashion, it was renamed to InfiniBand. Seriously, that's as 1999 of a name as you can get. InfiniBand allows storage, servers, and networking hardware to all be connected and managed centrally using a switched fabric network topology. To grossly oversimplify, you can connect whatever you want and get a high throughput and low latency, and it's also scalable. To put the InfiniBand spec into reality, though, you need hardware, just like you need hardware to make USB or PCIe work, and that's where Mellanox leapt in. Michael, what would surprise people about these computing clusters, and what makes one interconnect work and another one not work?
Well, at the end of the day, you need to scale your application across many machines, and it means that now it's not the application or service, if you wish, build this sort of is an application built out of the many microservices, which is sort of collaborative applications and running everywhere in the data center, and they need to talk to each other in the most efficient manner. That's what it's all about. It's how to make many applications or many processes running on the single machine, talking to many other processes running on many other machines, and it's all needs to be done in the way that it is they can scale up and down based on the demand. Now all the internet services on the big service providers, cloud service providers, are built based on our technology. It started at the high-performance computing, bare metal, if you wish, clusters or scale-out applications, and now it gone to cloud, and all the cloud stuff is built on this technology.
I assume you went fabless?
Yeah, well, very few companies have their own. Even AMD doesn't have their own fab.
Right.
They used to have, but not anymore. So making silicon is very, very expensive. Building fab is billions of dollars. And Intel has their own fabs, but definitely not startups. The overhead of building fab, developing processors and process technologies, and moving it from one generation to another, it's art on its own. It becomes the service, like many things become service. Even computing and storage today is a service and not the server, let alone the fab.
Fabs are definitely non-trivial, no doubt about that. So if we fast forward to 2019, Mellanox, the company you co-founded, gets acquired by NVIDIA for $7 billion, and it's the second largest sale of any Israeli company. Clearly, this is a passion project for you because Israel is beautiful and you could just be hanging out on a beach somewhere?
Yeah, people ask me about retirement from time to time, and when I ask, what does retirement means, they say, basically, you do whatever you want or whatever you like, and you get paid, and that's all good. So I thought it means that I actually retired at age 25. Because very long time I'm doing what I like and what I want, and I get paid.
Can't argue with that logic. Now, I'm admittedly not very tuned into the main players in the high-end space, and I, not knowing what I don't know, wouldn't have put NVIDIA very high on the list of potential buyers for Mellanox.
When I was thinking, with who would acquire Mellanox, NVIDIA was pretty high on my list, and they acquired us. And the reason is that NVIDIA is, it's sort of, they started as a GPU company, which is graphic processors accelerators company, but GPU now is a general processing unit. It's not graphic processor anymore, and NVIDIA is the accelerated computing company that are building the infrastructure and the platforms for AI. And this is something which is extremely hungry and thirsty for the network, and the services that we talked about, these microservices that are spread across the data center, AI and all these workloads is sort of extreme case of this. So, if you look what NVIDIA have been doing last 10 years, or maybe even a little bit more than 10 years, it was very natural that they would need high performance communication. Actually, we worked with NVIDIA before acquisition for about 10 years. So we knew these guys very well. It's a great company. They had the great computing. They didn't have a state-of-the-art networking, and we worked together to build the solutions. The supercomputer that was I think more than 2 years, number one, which is the Oak Ridge Lab machine, is built with the NVIDIA GPUs. There was few IBM CPUs and a lot of Mellanox interconnect. So it was very natural for NVIDIA to acquire Mellanox, and that's what they did.
It sounds like you'd been working with them for quite a while then.
Yeah, we worked not from the beginning, but I think more than 10 years we worked very close to the. Once we got to the higher sort of scale and to the data centers and the AI also evolved, and NVIDIA basically became the leading provider of the computing for artificial intelligence, and they needed interconnect. So we worked together to make the solutions, and now we are one company.
What about AI and GPUs plays well together? Where is the technology overlap there, and how do they enable each other?
Well, the artificial intelligence, it's the neural network based neural network model, and if you go down to the math, it is extremely parallel workloads. It's operation of at the end of the day. If you go down to the bits and pieces, it's operation of the matrices. The technology of vector processing that was developed for graphics, which is also very parallel type of operations, was this core technology becomes very applicable for the AI and neural network type of data processing. So the first application was sort of taking GPU as is and start working with the data types they had for graphics. And eventually NVIDIA added more data types and more support for AI applications and AI workloads, including better interface with the interconnect and the ability to scale out. They also developed that was before acquisition. They developed their own switches called NVLink to enable GPU clustering at a lower scale, and with Mellanox they can go pretty much sky's the limit.
Fascinating. Yeah, I was looking at a machine learning algorithm the other day, and it was like a voice recognition thing. It literally turned the voice print into a PNG picture and compared the two files to the reference. So it does make sense that GPUs would be critical in that sort of role. If I wanted to build a supercomputer from the ground up, where would I start, and what are things I should watch out for?
Well, you need
it's a big question, I know.
Yeah, it's a big question, and you need to look at what type of the things what you are looking for. But I would start of thinking about this as the cloud service. Now, if you ask Google what do they have, they will tell you that they have a huge supercomputer. They just run their services on top of it. So what you need to have a good CPUs. You need to have a good accelerators, and you need to have a great connectivity, great interconnect. So, and NVIDIA now has also, there was introduced the Grace processor, which is going to be great with the NVIDIA GPUs together, along with Mellanox interconnect. It is like CPU, DPU, and GPU are the three pillars of data center computing, and that's how I would build.
I understand GPUs and CPUs pretty well, but DPUs were a new one on me. And instead of me trying to explain what they are, here's a snippet out of an NVIDIA blog that describes what a DPU is. I'll put a link to that post in the show notes if you want to do more reading on them. I quote, "A DPU is a new class of programmable processor that combines three key elements. A DPU is a system on chip that combines, first, an industry standard, high-performance, software programmable, multi-core CPU, typically based on the widely used ARM architecture, tightly coupled to the other SoC components. The second thing in a DPU is a high-performance network interface capable of parsing, processing, and efficiently transferring data at line rate or the speed of the rest of the network to GPUs and CPUs. And third, a rich set of flexible and programmable acceleration engines that offload and improve application performance for AI and machine learning, security, telecommunications, and storage, among others. All these DPU capabilities are critical to enable an isolated, bare metal, cloud-native computing platform that will define the next generation of cloud-scale computing. If you want to do more reading about that, because there's a lot more in that post, you can check out the show notes on allaboutcircuits.com. And now back to our interview with Michael Kagan, the CTO of NVIDIA. Is there anything that you find especially interesting or cool about supercomputers that maybe wouldn't make it to a press release, but would be really interesting for the engineers that are listening?
There is a new way to do the data processing these days. And it actually, we are in the midst of the revolution. Artificial intelligence, I think it's the most significant technology for many years out there. It changes our life.
Why?
Why? Because you can live in the world that are half virtual, half physical. You can collaborate across the ocean. You can, we are now talking. There is a lot of AI stuff, by the way, in between us. You might not be aware of, but it is there.
What makes this a revolution, and why is AI going to impact our lives going forwards?
It's everywhere. Now we are talking. There is AI in between us. Okay, we can the chatbots. A lot of them are actually artificial bots, not really people. Help, let alone Facebook that knows what you want to do, and that Amazon that knows what you want to buy, and your insurance company knows when you are going to have a car accident.
Well, if you speak to my AI insurance algorithm, be sure to put in a good word for me. Tell me, how do supercomputers and data centers play together? Are there similarities? Are they identical?
Well, the data center and the supercomputers is a matter of deployment of what type of workloads you're running, but basically they're converging to be pretty much the same thing. And data center base architecture of high-performance data processing, high-performance communication, and clear segregation of infrastructure layer and application layer, application tiers and infrastructure tiers. And the way the resources are being managed and provisioned, this is what is happening in the data center. And actually, data center becomes sort of a new unit of basic computing.
Help me wrap my head around why a data center is a new unit of computing.
Because when we're working on the von Neumann machines, then you're sitting and typing your program. You create the program, basically write C code or Fortran code or whatever you're running, and then you need to compile it and run as application on the machine. And so in order to create the program, you need pretty much the compute power of the type recorder or word processor. But then you need to run your program on the supercomputer, like simulation or CAD tools or whatever. When we talk about the AI and these neural network models, the way you create the program is you actually train the model. So you need to run a lot of data through your model and tune the parameters. And it takes a huge amount of computing for a very long time. And then once you train the model, you prune it, you tune it, and then you put it on your cell phone. And so it's sort of other way around. It used to be very little computing to create the program and then a lot of computing to run it. Now it's other way around.
So now it takes a lot of computing power to create the program, like, say, train a neural network, but not as much computing power to actually run it.
So it means that the data center becomes a unit of computing that needs to be accessible for all those that want to create the program, and nobody can, or very few people, definitely not individuals, can afford to build to have its own data center. So the computing becomes a service. It's not a server anymore. It's like you don't have the power generator at the home. You use the services from the power company, from electricity company. The same, you don't have a computer at your home. You use the computing services from the data center.
I'll add that to my list of bills to pay every month: utilities, internet, and supercomputing. Where does this go, and how does it play out?
this sort of and this data center architecture, this data center as a unit of computing, it can scale to to huge hangars, hunger scale data center where you have hundreds of thousands of compute elements wired together, creating this computer, all the way down to to autonomous car. It's also data center on the wheels, and you go to telco, which is becoming also service provider. They have a lot of data going through them, and you can always have services based on them, not just move the bits from one port to another. And the same concept will go to edge, to even to IoT devices. There is like you have a watch, and you can now on the smartwatch you can install the applications, and you want to make sure that your application that you install there doesn't break your watch, because at the end of the day, sometimes you do need to know what time is it now.
I do sometimes use my watch for telling time, but that's not the main use case. Yeah.
Yeah. At my smartphone or cell phone, I think the least used function of this cell phone is actually the phone.
Totally. Can you expound a little more on how edge computing and cloud core supercomputing play together? Are they cohorts going after the same thing, or are they kind of siloed separately from each other?
They complement each other. Edge computing, what does edge computing means? It's a smaller instances of the data center that are outside these big buildings with a lot of machines. They essentially doing the same thing at different scale and closer to the data source and closer to the point they want to impact. So when they do both a lot of inference and some training, and they communicate with the data center, but this communication is they update the models and so on and so forth. But if you look at the smart cities and the like, you will have a small data center on every pole. The car is the data center. The autonomous car is the data center. I just read in the newspaper the other day that Toyota is cutting down their production by about 40% because there is a shortage in the chips. Okay, so it's when you buy a car today, you actually buy the data center. It happens to be on the wheels, but it is the data center.
If I wanted to stay up to date with the up and coming supercomputing technologies, what are topics I should put on my radar?
I think a lot has to deal with the collaboration and digital twins, for example, is something that you need to look for. This is going to happen.
If you aren't familiar with the term digital twin, it's one you need to know. A digital twin is essentially a virtual digital copy of a physical object or process. The idea has been kicked around a lot over the years, but one of the first real examples of it being used in practical times was by NASA in 2010 to improve upon physical models of a spacecraft.
Today, the simulation of the real world, of the real physics, is one of the things that are going to come up. Like, think about that. In order to train the model that commands or drives the autonomous vehicle, you need enormous amount of driving time, which is outside our lifespan. So that's where simulation is coming. You simulate the real world, and you don't really want to have a real accident to make sure that your model is trained right. So you do it on the simulation.
So what you're saying is that we need more data and more training time than we have in our lifetimes. So simulation is going to be a big factor in the future.
That's right. Yeah. Virtual reality and the real simulations of real physics. That's the key.
How far are we from the Matrix situation where we're all just living in simulations full time?
Oh, I think some of us already there. Frankly, I didn't even see the movie. I just heard about it, so I'm not I'm not in the details. But you call the helpline, or you use the chat to get the help from Microsoft or any. You don't really know whether you talk to a real person or to AI, some sort of bot.
Yes, it's creepy how good it is.
Yeah, and they're helpful. sometimes.
Is there anything in media or in fiction that people just get totally wrong about supercomputing, or anything that just like really bugs you when they say it the wrong way?
Well, I think the basic wrong thing is that people are afraid of it. It will happen. Okay, it's coming there, and the thing is that people will stay unemployed or whatever it is. Nobody got unemployed because you don't need to have somebody to ride your horse. You can drive your own car.
So you're saying there are still going to be jobs, they might just be different jobs. Like, I don't have a carriage driver to drive me to the office, but the auto industry is a huge source of jobs.
It's like a spiral. There's the technology that addresses some of our needs, and as a result, our needs are growing, and now we need to develop more technology to address these needs, and so on and so forth. It's like communication. It's like transportation. It's everything. Now we there started the communication beyond the pigeon mail. There was voice communication like telephone. Then we are now talking on video. We can transform not only the audio but also video, but we don't transform yet the perception. At some point we'll get there. So we'll have a more and more feel like we are together. And the great example is the Corona pandemic. That's worldwide event that moved everyone to work differently, to change our lives. And I'm working in the United States, and I'm sitting at my home in Israel. It just my working hours a little bit skewed. But if not this technology, I would have to be in my role at NVIDIA. I would have to be at the headquarters, and now I'm on the headquarters while I'm sitting in my home in Israel.
You are the headquarters. You're the CTO.
Yeah, well, I mean.
You recently released some graphics cards with limited hash rates to prevent crypto mining, but it doesn't impact other more typical uses for a graphics card. Using this as a case study, how do you go about creating cards with this type of specificity, and what's the strategy and mindset behind it?
Well, you develop the basic technologies, and then you proliferate it and adapt, adjust to different needs. Sometimes it's new hardware, sometimes it's a lot of software with the software support or microcode support. But you have this basic technology of processing. You evolves with the new data types and new accelerators for specific uses.
There have been some attempts to work around the limited hash rates. How much is security and IP protection something you have to think about as CTO?
Well, security now it's really in the data center. Security is not an option. It's the must have. Now, we talked about people actually using the data center as their main processing media of their data. Some data is very confidential, either on the personal level or government level. Some regulations, and cybersecurity is next the warfield. You can create much more damage by breaking into the country infrastructure. You can create much more damage than some terror act. If you make all the computers on the airplanes stop working, airplanes will start falling apart.
Speaking of airplanes falling apart, let's jump into some lightning round questions. How has it been taking on the CTO role for NVIDIA, and what's a day in the life like for you?
NVIDIA is a very technology-rich company, and after more than a year at NVIDIA, I still feel like I'm drinking from the fire hose. There's a lot of things that I'm learning, and we are putting together the strategy and the roadmap of how to make even better computers.
When it comes to gaming, you have NVIDIA, which is a company that is probably almost not split down the middle, but has a very strong gaming presence, and then this very strong high-tech computer presence. How does that work in a company? Are those siloed, or do they bounce ideas off of each other?
Yeah, of course they bounce the ideas together, and in order to make a great game, you need to have there's a lot of great underlying technologies. And the gaming starts, it can start on your computer at your home, and it goes to the cloud. There's a cloud gaming services by NVIDIA as well. We have this GeForce Now servers you can sign up and play games, and you can play the same game in the cloud, or you can play it on your computer, and it's all scalable up and down. Gaming industry, I think gaming is going to, game is one thing. It's now you go to this virtual augmented reality, which is same base technology.
So what are we going to see in the future, both for gaming and AR, and is gaming driving forward AR, or is AR just adopting practices that gaming is developing for gaming's sake?
Well, the things are going in circles. It's not always obvious or always clear who drives whom, and actually everybody drives everybody else. Depends on the time and some specific things. But gaming created these real physical simulations, and now we have real simulations of real world as a part of the games, and so on and so forth.
So we were talking about simulation earlier. I imagine there's a lot of overlap there.
Yeah, right.
Looking at the future of NVIDIA, one of the things we have to talk about briefly is the acquisition attempt of ARM. Assuming that goes forward, will ARM technology complement the current portfolio, and how is that going to play in with NVIDIA's offerings?
Well, the NVIDIA, the data center is built on the three basic pillars, which is CPU, GPU, and the DPU. And ARM is the CPU. So, the acquisition was announced. It's now hopefully it will be approved.
There was some public concern around keeping ARM open source. Can you comment on the value of open source to the tech community at large, and maybe the value in removing that open source component and keeping things in-house?
Well, open source is great value for community, Linux, and there's a lot of open source development out there. NVIDIA is in the Mellanox before as well. We were very, very active in the open source community on the networking, and it's part of the joint development in the industry. Do
you play any video games? And if so, what's your favorite?
No, I don't. I do use my phone a lot, both audio and video communications.
Okay, fair enough. You play, server interconnect speedruns or something like that.
Yeah.
Michael Kagan, thank you so much for being here. I've learned a lot, and I'm sure our lobby listeners have as well. If you like this podcast, the best way you can help it out is by sharing Moore's Lobby with a friend or colleague that likes to geek out on tech as much as you do. And if you're a Lobby fan, you are also going to love Industry Tech Days 2021, which kicks off next week on September 13th. Industry Tech Days is the electronics conference and trade show of 2021. Plus, it's free and you can join from your desk at allaboutcircuits.com. Join me for 5 all-star keynotes, including Arduino co-founder Massimo Bonzi, 2 NASA astronauts who just came back from a 6-month engineering bonanza in space, an executive panel with folks from DigiKey, Microchip, and TTI discussing the global chip shortage, and others you won't want to miss. You can browse booths from the world's most trusted manufacturers and distributors, as well as interact with industry experts like yourself during 50 other live sessions. And finally, you can enter to win a grand prize and some pretty sweet swag. Sign up for Industry Tech Days 2021 on allaboutcircuits.com today. The event goes live September 13th and runs until September 17th. One last thing, I'd also like to invoke everyone's help here. There are some spicy internet threads about how to properly pronounce NVIDIA. I propose a name change. How about In-N-Out Vidia? And as a bonus, they can overclock GPUs and cook burgers on them. Let's make this happen, people. Thanks for listening. I'm Daniel Bogdanoff, and I'll catch you on Monday for Industry Tech Days. Go sign up right now at allaboutcircuits.com. It's going to be a blast.